Hello and welcome back to another tricky A-level maths exam question. So as we can see here from the bottom left corner, right, this is question 8 in our series on tricky A-level maths exam questions. And if I do say so myself, I'm not being biased here, but if I do say so myself, I think I've chosen a pretty good question for today's video. Now, what do we have then for this question here? Well, what I've got then is f of x here, right? As we can see then, we have this quotient of functions. And all we want to do here then is just differentiate f of x to obtain f prime of x, right? And we should obtain something in this form here. Now that all sounds very straightforward, right? You might be wondering, why is this question so difficult? Well, I've got two problems here, right? Within my numerator, I also require the product rule. So we already require the quotient rule here. We have a quotient of functions. As we just said then, within the numerator here, we also have a product of functions. And within the denominator here, we also require the chain rule, right? So for this question, then, there is a little bit of everything here in terms of differentiation. And just generally speaking, this question here does really require some strong algebra skills and, some decent differentiation skills, right? In terms of the differentiation, it's not the most challenging, it's just the product rule, the quotient rule, and the chain rule. So nothing particularly challenging there, but putting it all together and the strong algebra skills required does make this question particularly challenging. So let's just work through this together then, but feel free to pause it now, have a quick go. As I've already said here, you should obtain something like this where a and b are just constants to be found. If you don't get anything like this, then clearly you've messed it up. You can either have another go or just watch along with us here, right? And let's just see how we can do this together. So let's just start then with the quotient rule here. So I've got u as my numerator, so that is 7x e to the x here. 7x e to the x, just like that. And then for v here, that is my denominator. So I've got the square root of e to the 3x minus 2. To make my life a little bit easier here, what I'm going to do then is just write that as e to the 3x minus 2 all to the power of 1 over 2. It just makes my life a little bit easier. So I've got e to the 3x minus 2 all to the power then of 1 over 2. Just like that, right? Now, what we also require here is the respective derivatives. So u prime and v prime. Okay. Now, u prime, as we've already mentioned here, does require the product rule. If you're not dumb like me, you can just do this off the top of your head, but I'm dumb and I always make silly mistakes. So I'll do it properly just to avoid any potential mistakes. I would just generally recommend doing it anyway, just to avoid any potential silly mistakes here, because clearly if I get this wrong, then the remaining part of the question will clearly be incorrect as well. So rather than potentially saving maybe 30 seconds, just do this properly, right? So u prime and v prime here. So if I take u then as 7x, and I'll take v here as e to the x then, u prime is just simply 7, and v prime, again, is e to the x, right? So putting this all together then, what I get here is 7x e to the x, so 7x e to the x, plus 7 e to the x, right? So plus 7 e to the x there. Perfect. If you want to as well, you can also factor out a 7 e to the x, so you don't have to, but you might just find it makes life a little bit easier. I'll do it anyway. So as we just said then, 7 e to the x here, and then bracket 1 plus x, just like that. And then for v prime here, again, as we've already mentioned here, this does require the chain rule. So the 1 over 2 comes down in front of the bracket. I'm going to get 1 over 2, just like that. I then times this here by the derivative of the inside of the bracket. So the derivative of the inside of the bracket here is just simply 3e to the 3x, right? So 1 over 2 times 3e to the 3x. I then have the original bracket here. So e to the 3x minus 2. And then all I need to do here is just reduce the power by 1, right? So 1 over 2 minus 1 is minus 1 over 2. Perfect. And if we really want to here, again, I can just make my life a little bit easier then. So what I'll do here is rather than writing this as 1 over 2 times 3e to the 3x here, I can just write that as 3 over 2 times e to the 3x, right? Let's just do that here. So grab my pen again. I get 3 over 2. So 3 over 2 e to the 3x bracket e to the 3x minus 2, all to the power then of minus 1 over 2. Perfect. So at this point here, we're nearly 5 minutes into this question here, And we're not particularly, far into the question, but I'm just kind of laying the groundworks here and the foundations to kind of tackle this question, right? And I would definitely recommend doing something like that for this question here, where you've got kind of a lot of things going on. Be very, very careful with how you lay out the question, okay? So let's just start then by applying the quotient rule here. So for the quotient rule here, I do v times u prime times these ones together here, like so. And then I do v prime times u, and we subtract that from this one here. Okay, we times those together as well. So what do we get here then? So I'm going to get 7e to the x bracket 1 plus x times this here. I'll just do this underneath them. 7e to the x bracket 1 plus x times by this here. So e to the 3x minus 2 all to the power then of, I'm going to say minus 1 over 2, but it's just 1 over 2 here. Just be very, very careful with your signs. It's really easy to make a kind of like silly mistake like that. We then subtract this product here, so minus them. So what do we have here? So I've got 3 over 2 e to the 3x times e to the 3x minus 2 all to the power of minus 1 over 2 times by 7x e to the x, right? So I can write this here as 3 over 2 e to the 3x bracket e to the 3x minus 2 to the power of minus 1 over 2 e to the 3x minus 2 to the power then of minus 1 over 2. And then we times this here by 7x e to the x, right? And don't forget then that all of this here, so this is my numerator for the quotient rule. We then divide this by v squared, right? So v here is my denominator, so that's the square root of e to the 3x minus 2. So if you square that, v squared, then we just simply get left with whatever's underneath the third here. So I get e to the 3x minus 2, just like that, right? Perfect. Okay. So where do we go from here? And this is where the kind of like strong algebra skills are now required, because I've got this here, but clearly I need to kind of manipulate this to obtain this form here. So where do I go from here then? So what I'm now going to do here, and I'll do that over on this side here, is I'm going to start then by times in both the top and bottom of my derivative here by e to the 3x minus 2 to the power of 1 over 2. The reason for that is because I want to get rid of this here, right? This e to the 3x minus 2 to the power of minus 1 over 2. That's pretty grim. I don't want that here within my expression. So what we'll do here, I'll make a note as well. We times then by e 3x minus 2 to the power then of 1 over 2. So if I do that here, what do we get then? So I've got this here. So I've got e to the 3x minus 2 all to the power of 1 over 2. So if I times that by itself again, I'm essentially just squaring it. And in that case, I just get left with whatever's underneath here. So this is a third, right? This is just this here. I just get e to the 3x minus 2 again. So I've got 7 e to the x times 1 plus x. We then get this here. So I get e to the 3x minus 2. So e to the 3x minus 2, just like that. I've then got this here. Now we're timesing this here by e to the 3x minus 2 to the power of 1 over 2. It just gets rid of this here, right? So I've got minus 3 over 2 e to the 3x times by 7x e to the x, right? We times that by 7x e to the x. Perfect. And again, that's all over v squared. Now, v squared again, we need to times this here by e to the 3x minus 2 to the power of 1 over 2. Clearly, we need to keep this fraction equivalent. I can't just times the numerator by this. So what I get here then is, so I get e to the 3x minus 2. And then we times this here by e to the 3x minus 2 to the power then of 1 over 2. Now we can make life easier again here. My base is the same, so this is the power of 1 times by the same base here with a power of 1 over 2. So it's basic laws of indices here. Gives us 3 over 2 as my power. So let's just eliminate that here. Make this look a little bit neater then. In fact, I'll just write it in the middle. Just keep it somewhat neat. So as we just said then, we get e to the 3x. So e to the 3x minus 2 all to the power of 3 over 2. Now, instantly that's positive, right? Because what I can see here is within the denominator here. They have an e to the 3x minus 2 to the power of 3 over 2. We've just obtained that here. So that's looking good. Let's just keep going then. Now, this fraction here, 3 over 2, again, pretty grim. It's not quite as grim as what we had here, right? But I don't want it. So what I'm going to do here, again, I do this to both the numerator and the denominator here of this fraction. I'm going to times them both by 2, right? So we then times by 2 here. So if we times by 2 then, what do we get here? And obviously just make sure that you times each term by 2 here. I can't speak anymore. So 7 e to the x here, if I times that by 2, I get 14 e to the x. So I get 14 e to the x, bracket 1 plus x times by this bracket here. More than anything, the most painful part of this question is just writing it down each and every time. It is tedious, but you get the idea. E to the 3x minus 2, just like that. If I've got 3 over 2 here and I times that by 2, I just get minus 3 then here. So minus 3 e to the 3x. I then times it by 7x to the e to the x here. Sorry, I think I mispronounced that. So I times it by 7x e to the x. There we go. English is really hard, much harder than math. So if you want to here, what you can do then is just times 3 by the 7 as well. Or the 7x, I should say. So just to save me writing this all out again here, what we get here is, so I get minus 21x e to the 3x times by e to the x, right? Just like this here. And that's all over then. E to the 3x minus 2 all to the power of 3 over 2. There's way too many powers for this question here. E to the 3x minus 2 all to the power then of 3 over 2, just like that. Right, so what can I do here? Oops, I forgot to times the denominator by 2 as well. Just get 2 lots of that. There we go, before I make that mistake. And where do we go from here then? So I can see here that for this question, we require a 7 e to the x here as a factor outside within the numerator, right? So I'll do that here. And I'll pull out a 7 e to the x as a factor. So I get 7 e to the x here. So inside this bracket, then I get 2 lots of this here. So 2 bracket 1 plus x times e to the 3x minus 2, just like that. Again, putting out a factor here of 7 e to the x here. What I get then is minus 3x e to the 3x. Okay, I put out the e to the x here as a factor. And that's all over then. 2 bracket e to the 3x minus 2 all to the power of 3 over 2. So just notice at this point here, we have the correct denominator. So I'm not going to touch the denominator again here. That's perfect. I'm just going to leave it as it is. Now, what about the numerator here? We're starting to get pretty close. Clearly, there is a little bit more work involved here because I'm not quite at the correct point. But what I'll do here is I'll just start by expanding these double brackets here, right? You can just use FOIL or any method that you're familiar with. It really doesn't matter. Just expand them correctly, basically. So let's just go back to the top here, just so I've got a little bit more room because we are starting to run out just a little bit here. So the 7 e to the x here just stays on the outside. So 7 e to the x, like that. Now, inside the bracket here, I get 1 times e to the 3x. That's just e to the 3x, but times that by the 2 here on the outside. So I get 2e to the 3x, like that. I've then got 1 times minus 2, so that's minus 2. Times it by 2 here, I get minus 4. So minus 4 there. I've then got x times e to the 3x, so that's x e to the 3x. So times it by 2, I get 2x e to the 3x. So plus 2x e to the 3x here. And then finally, x times minus 2 gives me minus 2x. Times it by 2 again, I get minus 4x. Just like this, right? I've got minus 3x e to the 3x here. And that's all over then. 2 lots of e to the 3x minus 2 all to the power of 3 over 2. Perfect. Let's just keep going here. I do appreciate that this question really is quite long. I can already see that we're pretty much at 15 minutes just for this part of the question here. But we're not too far from now, right? So what I've got here is 2x e to the 3x minus 3x e to the 3x. So what I can do here is just collect like terms, right? So I've got 7 e to the x, 7 e to the x, bracket. I've got 2e to the 3x here. I can't do anything with that, so I'll just leave it as it is. So 2e to the 3x. I've got a minus 4. Again, I can't do anything with that, so I'm just going to leave it as it is. This here and this here, we can collect those together, and that just gives me minus x e to the 3x. So minus x e to the 3x, just like that. And then what else have we got here? I've got the minus 4x. Again, I can't do anything with that. So just leave that as it is. Close those brackets. And again, this is all over 2 bracket e to the 3x minus 2 all to the power of 3 over 2. Perfect. We're getting close now. We're nearly there. So to finish with here, we need this form, right? So what I can do here is I can group some terms together, right? So I can group these e to the 3x terms together here. I get 7 e to the x. And I need to be a little bit careful here because I'm basically running out of room. So 7 e to the x, bracket. I've got 2 e to the 3x minus x e to the 3x. I've got minus 4 and minus 4x here. So minus 4 and minus 4x there, just like that. And that's all over 2 lots of e to the 3x minus 2. That's all to the power of 3 over 2 here. Now, I appreciate as well, if you're working through this question here, you probably think I'm kind of dragging it out, which, to be honest, I am. The reason being is because I want to show each and every step as I go through the question, because with questions such as this one, it can be really easy to kind of fail to see where the next step kind of comes from. So that's why I'm trying to show each and every step as I go. Because if I kind of jump from this line here to this line here, some students won't understand how I kind of got to that point. However, if I kind of explain it like this here, where I kind of group the terms together and we simplified here, it hopefully is a lot easier. Now that we've grouped these terms together here, what I can now do is apply a factor of e to the 3x. So once I do that, hopefully we obtain the desired result here. So f prime of x here is equal to, so I get 7 e to the x then. Let's just apply the factor of e to the 3x here. So we get e to the 3x then on the outside. So e to the 3x, what do I need then for 2 e to the 3x? Well, that's just 2, right? And then what do we need here for minus x e to the 3x? If we've got a factor of e to the 3x on the outside, well, that's just minus x, right? Perfect, that's promising. I've got a 2 minus x here. We've got a 2 minus x here. We've got plus ax, so that's minus 4x in this form here. Just like that. And then plus b, where plus b here is my minus 4, right? Just like that. And this here is all over then 2 bracket e to the 3x minus 2 all to the power of 3 over 2. Perfect. So there we go. Like I said, the actual differentiation as such is pretty straightforward. You know, it's just the product rule here. Well, that's the quotient rule there, product rule here, and a little bit on the chain rule, as we can see here. So in terms of the differentiation, that's all pretty straightforward. But more than anything, it's just the algebra skills here. As you can see then, there's quite a lot of steps involved with this question. Now, like I said, you can probably break this down into a few smaller steps than what I've done here. I'm kind of dragging it out a little bit, as I said, just to show you each and every step as I work through the question. But there we go. So this here is your solution. Let me just quickly highlight that in a different color. So this here is our desired result. QED, proof complete, whatever else you want to call it. But there we go. I am tired now. That was pretty much 20 minutes just for the first part of this question. Like I said, you can probably do it much quicker than me, but I'm trying to explain everything as I go. But there we go then. That's enough of the yapping. And that gives us the solution to question 8. As always, thank you for watching.